Okay guys, today we are going to discuss electrolyte. You will classify compounds as electrolyte by testing their conductivity in aqueous solution. So I need for you to follow with me on your paper exploring electrolytes. So what I have here, I have my virtual lab, and I'm going to the stock room and pull out some substances, and we will be testing them. Right here in the storage room, I will pull out sodium chloride, put it on the counter, and I have sodium carbonate. Sodium carbonate is here, and I will also test sodium bicarbonate. Sodium bicarbonate. So let's go back in the room. I need for you on your paper under chemical formula to write down the formula for those three chemicals. The formula for sodium chloride is NaCl. Let's do one by one. NaCl. Okay, the first one, NaCl, I put it by the balance area, and I'm going to pull out a beaker in my drawer here, and we will go to get some sodium chloride in the beaker. Let me open the jar. I get my scoop. I get some sodium chloride from my jar and put it in the beaker and go back in the lab. So I have my beaker here. Sodium chloride ionic compounds as a solid, it will not conduct electricity. What I'm going to do, I'm going to add some water to see if it will conduct electricity. Alright, let me get my graduated cylinder and fill it up with 25 ml of distilled water. Put it in the beaker, and I'm turning my stirrer on so I will dissolve it. I have here a conductivity meter which I will turn on. And then let me put the probe. This is a probe for the conductivity meter. I put it in my solution. Okay, conductivity in the beaker. And let's check to see if sodium chloride will conduct electricity. Yes, it conducts electricity. Alright, I can put everything back. I have a lot of beakers. I can put it in the recycling bin. Let's put that chemical back. Our second one is sodium carbonate. The formula for sodium carbonate is Na2CO3. Na2CO3. I will go back in the balance area and then get some. Let me open the lid. Get some of my chemical, put it in the beaker, go back in the lab, put it in the stirrer, add 25 ml of distilled water, and stir it. And I'm putting my conductivity probe in the beaker and check the conductivity. It definitely conducts electricity. So my sodium carbonate conduct electricity. Let's try a third chemical. The third one we will check is sodium bicarbonate. The formula for sodium bicarbonate is NaHCO3. NaHCO3. Get a clean beaker. I go back. Take the lid off, get some sodium bicarbonate, Put it in my beaker and go back in the lab. Put it on the stirrer. Add 25 ml of distilled water. We will stir it and check the conductivity. Yes, it does conduct electricity. So I'm done with those three. Let me get rid of this. Put the chemical back. Let me go back in the storage room. I will put them back. Now I'm going to pull out three more. I will pull out ammonium chloride. Ammonium chloride. Let's see if I can find ammonium chloride is right here. I will also pull down barium chloride. Barium chloride. It's right here. And I will pull out some ammonia. Ammonia is where's my ammonia? Ammonia is right here. Alright, go back to the lab. And this is my ammonium chloride. The formula for ammonium chloride is NH4Cl. NH4Cl. I get some ammonium chloride. Put it in the beaker. Go back and put it on the stirrer. Add water. Stir it and put the conductivity and check. Ammonium chloride does conduct electricity. Okay, let me put this in the recycling bin. Put that chemical back. Get my barium chloride, a clean beaker, the balance area. Remove the lid. Scoop some. Put it in the beaker. And I will add the same amount of water, so I will have a fair comparison for each one of them. And I add the probe, the conductivity probe, and check. Okay, it does conduct. Barium chloride conduct electricity. So let me put this back. Now I need a different techniques because this is a solution. This is a liquid. Okay, what do I do with the liquid? Okay, I need to measure it a different way. Let me get a clean beaker. Put my ammonia here. Let me get a clean beaker. Let's try to put the ammonia here. It's not staying here. I will pour some ammonia straight from the bottle to the beaker. Okay. And then, now that I have some, because I need to measure the exact same amount, why don't I get a pipette from that drawer? Let me get a pipette. I will get a 25 ml pipette since I use 25 ml for the others. Okay, so I press the bulb of the pipette, fill it up with 25 ml of ammonia. I can dispose, get a clean beaker, put exactly 25 ml, and then I will put it on the stirrer and check the conductivity. This is very light, very low. I would put slightly. It's almost no. I will put slightly. Okay, so now I'm going to do, I think we have space for two more. Let me clean everything. Okay, why don't I just reset everything, clean everything. Get clean. Let it go back to my stock room, put everything back. Now I'm going to pull out the last two, which is hydrochloric acid, HCl, and I will put cyanic acid or hydrocyanic acid, HCN. Okay, go back in the lab. Let me do the same thing. I will get a clean beaker, pour some hydrochloric acid in the beaker. And I get a 25 ml pipette and pipette 25 ml of HCl. Get another clean beaker to put exactly 25 ml. And then I check the conductivity. HCl. It's HCl ionic or molecular? It is molecular. It is made of two non-metals. But this is very, very strange. It conducts electricity. It does conduct electricity. Ammonia NH3 is molecular because it is made of non-metals. It still conducts a little bit, slightly. Something is very strange here. Now, let's check our HCN. HCN, which is molecular also because it is made of non-metals. HCN. Alright. Let me get a pipette. Pipette 25 ml of HCN. Use a clean pipette and put the 25 ml and check the conductivity. HCN does not conduct. HCN does not conduct. So I need for you, I'm just reading from number 2. Look at the data above and answer the following questions. Based on their chemical formulas, which solutes are ionic? Okay, I by mistake answered that question for you already. Do the ionic solutes conduct electricity? Based on their chemical formulas, which solutes are covalent? Molecular, covalent, same thing. Do the covalent solutes conduct electricity? Now, I'm going to add something here. I need for you to tell me if there is any exception here. If you saw any exception. And part 3, you need to predict whether or not each of the following solute will conduct electricity in solution. They give you some example, calcium chloride, and you have C3H6O and potassium nitrate. You need to predict if they will conduct electricity. Complete the final column as your teacher demonstrates the conductivity of each of the solutes. You need to do your prediction first and check with me. Each of the solutions that conducted electricity in the demo is known as an electrolyte. I need for you to create your own definition of an electrolyte using the terms based on their property and its relationship to chemical formulas and ion. So I need for you to complete this activity, answer those questions, and we will collect your work. So have a good time. Bye.